This is a short video on how do you find the solutions to a second order differential equation in the case that you've got two distinct real roots. And when you look at this equation, maybe it's not obvious off the bat that it'll have two distinct real roots, so I'll show you what you do in general. So the first thing you do is you take this differential equation and you write down what's the corresponding characteristic equation. And so what did we do? We took x double prime, we changed it to lambda squared. So change all the primes to actual exponents and change the variables you see maybe to lambdas. So like maybe that's not quite good, not a great way to say it, because like this doesn't have anything there, it's not supposed to. Anyway, think of this as like lambda to the second, lambda to the first. There's no lambda here, think of it as like there's no prime, so lambda to the 0. Anyway, this is the corresponding characteristic equation. This case, it's nice. It's always going to be quadratic for us for right now, and it factors. So if it doesn't factor, just try the quadratic formula. Anyway, you get lambda is -5 and lambda is 2. Remember too that this second order equation is the same thing, or it's equivalent to the system of two differential equations whose eigenvalues are these two numbers. So we just found the eigenvalues for that system if you like thinking about things through that point of view. Now what do you do after you get these two things? Well, what we're saying then is one solution is e to the -5t and another solution is e to the 2t, right? So that's how we use these two lambda values that you get. Something that I hope that you remember is, well, if you've got two solutions, then any multiple of either one of them is a solution, and any sum of those multiples should be a solution too. When I say multiple, I mean constant multiple, by the way. And so a quicker way to say that is that any linear combination, which looks like some constant multiple of e to the -5t plus some constant multiple of e to the 2t, when you add those together, that should be a solution to your differential equation too. That's one of the coolest names in this class. That's called the Principle Superposition, in case you're looking around at anything online about where that comes from, or if you wanted to see an actual proof of that. So, why is this stuff pretty nice? Well, as soon as you know that, as soon as you find these two different solutions that, and again, just come from the roots of your characteristic equation, as soon as you put them together like this, that's it. That's the general solution to the diff EQ.